Okay, let's read the question. If 3 liter of oxygen gas, if 3 liter of oxygen gas at 177 degree Celsius is cooled at constant pressure, that means, what is the meaning of cooled? Cooled, that means temperature goes on decrease. So we should decrease the temperature of the gas with constant pressure. We should decrease the temperature of the gas. We should decrease the temperature of the gas with constant temperature. From what temperature? 177 degree Celsius. That means initially 3 liter oxygen gas has temperature 177 degree Celsius. So after decreasing the temperature with constant pressure, after decreasing the temperature with constant pressure, that means the process must be constant pressure. The process must be constant pressure. So when we decrease the temperature, until the volume becomes 1.5 liter, until the volume becomes 1.5 liter, we should decrease the temperature with constant pressure from 177 degrees Celsius. When 3 liter volume of the gas becomes 1.5 liter. Okay, so we should decrease the temperature with constant pressure until the volume of the gas becomes 1.5 liter from 3 liter, until the volume of the gas becomes 1.5 liter to 3 liter. So when we decrease the temperature until the volume of the gas becomes 1.5 liter from 3 liter, then we get a particular temperature which has less value than this, because temperature goes on decreasing. So initially what is the temperature, then finally what is the temperature finally we get, which is less than this, because temperature goes on decrease. So we should calculate that temperature when volume of the gas is 1.5 liter. Okay, I think now I can understand completely question. Now we should calculate the value of final temperature of the gas. Okay, let's calculate. Firstly, we should write all the things which is given in the question. Okay, we should given 3 liter of oxygen gas. That means initially the volume of the gas is nothing but 3 liter. That means initially volume of the gas, let's suppose initial volume, which is nothing denoted by VI, given in the question is nothing but 3.0 liter, which is given in the question. And the next thing which is given in the question is nothing but initial temperature of the gas, which is 177 degree. Initial temperature Ti, that denote initial temperature with Ti, which is nothing but 177 degree Celsius. For we know that our all answers in options given in Kelvin. So we should convert this temperature which is given in a question in degree Celsius to Kelvin. So we know that to convert 117 degree Celsius to Kelvin, we should add 273 Kelvin in 177 degree Celsius. So what we get? We get 450 K. So we have given in the question initial volume which is 3 liter. We have given initial temperature Ti in the question which is 450 K. And the next thing we get until the volume becomes 1.5 liter. That means we have also given final volume. What is the final volume of the gas? What is the final volume, which is denoted by Vf, and what is the final volume? 1.5 liter. 1.5 liter. Okay. Then what we have to calculate? We have to calculate final temperature. So what is final temperature? Final temperature, that means TF, which is nothing but equals to which is nothing but equals to, we don't know, we have to calculate final temperature in this question. Okay, what is the next thing we should we have given in the question? What is the next thing we have given in the question? Which is process, that means throughout the process pressure remain constant. So this is also given in the question. Throughout the process pressure remains constant. Okay, these are the things which have given in the questions. Okay, so now we go forward to calculate the final temperature of the gas. Okay, we know that according to ideal gas equation, we know that ideal gas equation is nothing but, ideal gas equation is nothing but PV is equals to nRT. This is the ideal gas equation, where P is what? Where P is equals to pressure, V is equals to volume, R is equals to gas constant. Similarly, N is equals to number of moles. Okay, and the next thing is T is equals to temperature. Okay, so all alphabets have their usual meanings. P is equals to pressure, V is equals to volume, R is equals to gas constant, N is equals to number of moles, and T is equals to temperature. Okay, here given in the question, and R, we know that R is equals to constant, we know that, and N is equals to also constant given in the question. So N is equals to also constant given in the question. Let's we assume, because there is nothing given information about number of moles, so we assume number of moles of the gas is equals to constant. So we assume here he assume number of moles, जो कि which is denoted by N, is equals to constant, because we have nothing information about number of moles, so we assume number of moles in the gas is equals to constant. Okay, so we have P is equals to constant given in the question, we have also N is equals to constant in the question, and we have also R is equals to constant in the question. So take R constant terms on right hand side and all variable terms which is change with the process, take right hand side. Okay, let's do. So P upon में NR and T upon में V. So we know that P is equals to constant, N is equals to constant, R is equals to constant. So all these quantity equals to constant. So T by V is equals to, the ratio of T by V is equals to constant. We can see that. That means the ratio of T by V never change. The ratio of T by V never change. The ratio of, we can say that here, the ratio of T by V, T and V, the ratio of T and V, never change. Okay, because T by V is equals to constant throughout the process. What is the meaning of the ratio of T by V never change? That mean initial temperature upon में initial volume equals to final temperature upon में final volume. The meaning of this is nothing but the ratio can never change. The value of T by V which comes initially equals to the value of T by V comes finally. Okay, समझ गए? That mean initial temperature upon में initial volume is equals to final temperature upon में final volume. Okay, now I can understand. Okay, so what we have given in the question? We have initial temperature given in the question. We have initial volume given in the question. We have initial temperature given in the question. We have initial volume given in the question, which have also final volume in the given in the question. What we have to calculate? We have to calculate final temperature. We have to calculate final temperature. So put all these values which are given in the question and calculate final temperature. So what is initial temperature? Here we calculate initial temperature in Kelvin is nothing but 450 K. So what is initial temperature? 450 K. And what is initial volume? What is initial volume is nothing but 3.0 liter equals to what is final volume? Sorry, what is final temperature? We have to calculate final temperature. What is final volume? Here the final volume is nothing but 3.0 liter. Sorry, what is final volume here? 1.5 liter. Initial volume is 3.0 liter and what is final volume? 1.5 liter. Okay. And this is 1.5 liter. Okay. Now take 1.5 liter. Now take 1.5 liter and move from this side to this side after cross multiplication. So after cross multiplication, after cross multiplication, we get TF equals to, we move 1.5 liter from this side and we get 450 K multiplied by 1.5 liter divided by 3.0 liter. Here liter which is same, so it can be cancelled out. And we also know that 15 twos are 30. 15 twos are 30. So after solving this is cut from 2 for 2. Okay, so what we get? 450 K divided by 2 is nothing but final temperature. So what we get in final? 2 twos are 4, 2 twos are 4, 2 fives are 10 K. So what is the final temperature we get is nothing but 225 K. And when we check the option, we get 225 K on the position of option A. So what is the value of final temperature is 225 K. So our correct option is nothing but 225 K. So this option B, option C, option D, option E are not matched with our result. So only option A is correct. So correct option is A. So correct option is A. Okay, done. So this is the question. Solved question. Okay.